Hello everyone. Today we're going to cover lesson 2 from unit 1, and I'll get to that in just a minute. The first thing I want to do is talk about the assignment from last week. Got 18 slides here to go through to get all this done, so hopefully it won't take too long and get you on your way so you can start the assignment and be done with this and have some more knowledge and be more learned after we're done. So here we go. About last time, the conditional statements assignment. A lot of people didn't do it right, so it was pretty explicit. Write this conditional statement in if-then form. If you don't know what if-then form is, well, you weren't at class last time. You need to write them in if-then form. And a lot of you weren't using good punctuation either. I'd like to see capital letters and if something, comma, then something else, period. So write a real statement, not just some kind of gibberish. Write it in the correct form. It should be about you and or your hobbies. Remember, I had 2 goals here. Number 1 was you write a conditional statement and you understand what a converse is and you learn this stuff. And the second is, by grading them, I learn about you. So make sure that's something about you, something you enjoy. A lot of you wrote one statement and the second one was the converse of it. There should be 2 separate statements. So make sure you're doing 2 different statements. When you're doing these 2 statements, the first one should be a true statement, and the second one should be a false statement whose converse is true. So if you need help doing this, then here's 6 ideas on how you can get help. Review your notes. Remember, I require you to take notes. I'll be grading your notes here soon. You can pop back into class, because I'm waiting in class until the end of class. You can rewatch the lecture. The lectures are posted on in the Google Classroom. You can look in your book. I tell you what sections this stuff is coming from. You can come to my office hours after school. Office hours are 2 to 2:25, Tuesday through Friday. And I stay in there 10-15 minutes. If nobody comes, then I leave. So don't wait till 2:20 to come in. Come on in at 2 o'clock, at 2:05, that kind of thing. It's a Google Meet, and its nickname is Office Florence. So come on into that. Directions on how to get into it, again, it's Office Florence, but if you need directions on how to do it, those directions are in the Google Classroom. And last, I think this is the worst one, you can do an internet search. So you might get some slightly wrong information, you might get some slightly different information, you might get a lot more information than you can use, but you can always do an internet search for key words like conditional if-then statement, converse. Do a search for that and you'll come up with lots of hits. So I did look at all these. If you got a grade, then you can redo it if you want. If you got 20 points out of 20, you don't need to redo it. But if you got 18 or 19 points and you want a perfect score, you can redo it. If you didn't get a grade, but I gave you feedback about it, then you need to redo it and get the grade. So definitely redo it. Most of you did it, but didn't do it right, and I gave you some feedback on what you didn't do right. I'm giving you more feedback right now. And lastly, if you didn't do it at all, you can still do it for half credit, but at this point it's late, so it's only half credit. Alright, so that's my feedback on what's been going on up till now. You should know what a conditional statement is, you should know what if-then form is, and as I said, we're going to use them from now on in this class when we're doing proofs. Today, you can see up here, see my cursor up here? This is an introduction to algebraic proofs. It's lesson 2 out of unit 1. Unit 1 is logic. And the material in this lecture comes out of section 2.5 in the textbook. So today, I want you to get 3 things out of this. First off, I want to do a review of simple algebra. So mostly 2-step linear equations, but just a quick review of algebra. That's going to take probably the longest in this lecture. And then I want to talk about what algebraic properties are at work while we're doing these simple algebra problems. And I also want to introduce you to 2-column proofs. So most of you are probably going to recognize the algebra. Most of you will get that. Some of you are excellent at algebra. Some of you probably should have failed algebra and never should have joined this class, but your teacher gave you a D- out of the goodness of their hearts, and now you're going to have trouble in this class. but again, and some of you and the rest of you are somewhere in between. You're not excellent and you're not horrible. So there's a wide spectrum of abilities in here. I'm going to go slow so people who are on the lower end of the abilities can hopefully catch up. So you need to know the algebra. Algebra is a very important thing. And some of you probably heard of the algebraic properties. I'm going to present them as if-then conditional statements. And you need to know what a two-column proof is. You need to know kind of how they work. So we'll be doing geometric proofs later. Again, this is an introduction to algebraic proofs, not geometric proofs. So most of you haven't seen any proofs at all. So get right into it. Start off with this quick review of simple algebra. Here is a problem. 3x plus 7 equals 25. And we need to solve it. And to solve it means to find the value of the variable that makes it true. So hopefully you've seen this kind of analogy before. 3x plus 7, you always want to have a left-hand side and a right-hand side when you're doing these things. So divide it at the equal sign. There's a left-hand side and a right-hand side. It's much like a scale. Here we have 3 x's and 7 ones. So there's our 3x and 7 more. That's the left-hand side is 3x plus 7 is in this left-hand tray on the scale. And 25, there's 2 10s and 5 1s. So that's 25. That's in the right-hand side, the right-hand tray on this scale. And you can see they're balanced. That balancing point, that is the equal sign. The left-hand side and the right-hand side are separated at that equal sign. So the goal here is to find out what x equals. We got to get that x by itself. We want to get rid of everything on here except one x, and we want to see what it balances with. So moving on, here's how we're going to do that. This 3x plus 7 equals 25. Again, we want to make sure we separate the left-hand side from the right-hand side. We'll subtract 7 from both sides. If we just subtract 7 from one side, notice it's no longer equal. And on the left-hand side, we subtract 7, we get 3x. The right-hand side, we didn't do anything to that side. That's like doing this. We start off with our balance, we take 7 off the left-hand side, and suddenly they're not balanced anymore. Fundamental idea in algebra is you have to do the same thing to both sides, always. That's for sure, always same thing to both sides. And today we're going to talk about these basic properties of algebra. That's how you get this done. So here's how you do it the right way. 3x plus 7 equals 25. Separate it, keep the left-hand side and the right-hand side separate. And again, you always want to do the same thing to the two sides. If you subtract 7 from both sides, then if you have 3 x's, then you add 7 and subtract 7, then adding 7 and subtracting 7 will cancel each other out, and you'll just have those 3 x's. So the next step would look like this. You just have the 3 x's on the left-hand side. We did the same thing to both sides, subtracting 7 from both sides, and 25 minus 7 is 18. Now we have the 3 x's. That's what we did visually. Here it is. We started off with 3 x's and 7 on one side. On the other side we started off with 25. We had to break into one of these 10s. So there's one of these 10s, this one here maybe. We got 3 left and we took out 7 of those. So here's the 7 and there's the 3 that are left. So now we have 18 over here, and we take out 7 here, there's 3 x's. That's very much what is going on here. So 3x equals 18. They do balance. Same thing to both sides. Once we have that 3x equals 18, we can do things to that equation. So we can basically just start off where we left off. We know 3x equals 18. That's where we stopped on the last slide. So from here, well, make sure you keep the left-hand side and the right-hand side separate. There's our balancing point. Again, it looks like this. 3x is on one side and 18 on the other side, and they are balanced. And when you've got that, we don't care about what 3x balances with, what 3x equals. We don't know what is x equal. So we need to take 1/3 of these three x's. Our first goal is to get the x's by themselves. We have three x's here. Now they're by themselves on the left-hand side. If we take 1/3 of that, and we'll do that by taking the 3x and dividing by 3. So 1/3 of 3x is 1x. If you take x, if you have 3 x's, and you cut them into thirds, then you have each third is 1x. So to find a third, you divide by 3. Of course, we have to do that to both sides, or else we lose our equality. So we get x equals 6. 3x divided by 3 gives us a third of that, so that's x. 18 divided by 3 is a third of 18, is 6. So now we have 1x on this side and 6 on the right-hand side. We found out what x equals. That's how you do it, doing the same thing to both sides always. Get that x by itself. And just a quick note here about mental math versus algebra. Take this, x plus 5 equals 8. Most of you know the answer is 3, right? 3 plus 5 equals 8. The way you're doing that is you're using mental math. You say 3 plus 5 is 8, right? And if you need to check your calculator, you can enter 3 plus 5 equals, and it'll tell you, oh, the answer is 8. So yeah, 3 plus 5 equals 8. I know x has to equal 3. You didn't do any algebra to come up with that. You used mental math. When there's nothing wrong with mental math, this is a really easy problem, and you can mentally just figure it out. On problems like this, mental math is probably faster than algebra. The problem is, on more difficult problems, you can't just figure it out. You've got to know algebra to figure out the answers to more difficult problems. So that's why it's important to learn algebra. The way you would solve this using algebra is like this. You would take x plus 5, divide it into a left-hand side and a right-hand side. On the left-hand side, you would get the x by itself. So you would subtract 5 to get x. And on this side, you would subtract 5 as well, same thing to both sides. So 8 minus 5 would be 3. So you'd end up with x equals 3. The logic is different on these. Mental math, you just come up with the answer. Algebra, you solve for the answer. The logic is, with mental math, x equals 3 because 3 plus 5 equals 8. But with algebra, x equals 3 because 8 minus 5 equals 3. The logic is different. So, and again, mental math is a valid technique, but it's not algebra. So, a lot of you who want to keep using mental math and you think, oh, I just keep using mental math, I have to use this algebra stuff. This is why. When it gets harder, mental math breaks down and you can't do it, and you get frustrated because you never learned algebra in the first place. So make sure you're learning this algebra. Alright, moving on. So here we'll move on and talk about what algebraic properties are at work when you're doing algebra. So here's an if-then conditional statement. It says if two expressions are equal, so two expressions are equal, that's the hypothesis. So say like here, we've got x minus 4 is an expression, 23 is an expression, and they are equal. So we know this is true for some reason. So these two expressions are equal, we're given them. Then, if that's true, the conclusion is going to be true. You can add the same thing to both sides, and they will remain equal. This whole idea here, that this, you don't have to say, if two expressions are equal, then you can add the same thing to both sides and they'll remain equal. You don't have to say that. All you have to say is, oh, this is the addition property of equality. That's what this statement is called. This idea is the addition property of equality. So to use the addition property of equality, we can add the same thing to both sides. We can add 4 to both sides. And if we do that, guess what? We get things that are still true. On the left-hand side, we'll get x, because if we subtract 4 and add 4, that's the same thing as doing nothing. If we add 4 to this side, we get 27. So x equals 27. And we know that's true because the addition property of equality says it must be true, because this is a true conditional statement up here. It's completely valid. So that's how these properties work. Here we've got solving an algebra equation, and here we can say exactly what reasons we have. I got a couple more of these for you. We got 4 of these properties to go over. The addition property of equality. How about this one? The slide changed, it didn't disappear. Here we have if 2 expressions are equal. So for example here, we know these 2 are equal because they're given to us for some reason. We can subtract the same thing from both sides. Right? We want to get rid of this 12. The idea is to get the x by itself. So to get rid of the 12, we've got to subtract 12 from the left-hand side. If we do it to both sides, then these 2 expressions will maintain the equality, will maintain that balance. So around the equal sign, subtract 12 from this side, subtract 12 from this side, we have x. We're subtracting 12 and adding 12 on the left-hand side. So that leaves us with just plain old x on the left-hand side. That's why we did it, to get rid of that 12. Same thing to the right-hand side, subtract 12, got 29 over here. And this property says you can subtract the same thing from both sides and they will remain equal. These 2 remained equal. This idea is called the subtraction property of equality when you're subtracting from both sides. So how do we know x equals 29 is a true statement? We know it's true because of the subtraction property of equality. That's how these properties work. And by the way, remember there were 3 things I wanted to do today. Review algebra a little bit, and then talk about these properties, and then do 2-column proofs. And here when I'm talking about the properties, I'm trying to set up 2 columns. Here's one column with the work we're doing, and here's another column with the reasons that we know these things are true. So keep that in mind while I go through these. The next one, hey, guess what? If you have an equality and you multiply both sides by the same thing, you still have an equality. That's called the multiplication property of equality. So here's a quick example. If you have x times 1 divided by 4, or times 1/4 on one side equals 7, you know this is true. You can multiply both sides by 4. So 4 times 1/4, if you take 1/4 of something and then quadruple it, take 1/4 times 4, hey, you just have 1x. So we're multiplying by 4 to get rid of the 4 in the denominator here on the fraction. Same thing to both sides. Multiply both sides by 4, and you end up getting 1x on the left side and 28 on the right side. How do we know x equals 28? How do we know that's a true statement? It's because this multiplication property of equality says it is. If you start off with something true, you end up with something true when you multiply both sides. That's what this multiplication property says. And let's see, we did addition, subtraction, multiplication. Guess what the other property is? You can divide the same thing on both sides. So if 2 expressions are equal, there's 2 expressions, 0.2x and 2.8. They are equal, and we know they're equal because we're given them as being equal. Somebody told us, hey, this equation is true, can you solve it for me? And to do this, since x is multiplied by 0.2, we're going to divide to get rid of the multiplication. So we're going to do the same thing to both sides, divide by 0.2 on the left-hand side, and divide this whole side over here by 0.2. And if we do that, we'll end up getting x equals 14. And we know it's true because the division property of equality tells us it must be true. So those are the properties of equality you really have to know right now. Here, I did a quick review of simple algebra, and those are the properties we're going to be working with right now. So now I want to do a quick introduction to 2-column proofs. And they're going to look a lot like what we were just doing. Here we have 2 columns. One column has a bunch of statements in it. And again, these are algebraic statements. We're doing algebraic proofs. The second column has the reasons why we know the statements in the first column are true. So 2x minus 7 equals 29. We're given that problem. So what I'm going to do is I'm going to come in and I'm going to get rid of this 7. I want to get those 2 x's by themselves. So I'm going to add 7 to this side and add 7 to the right hand side also. And when I do that, I will get, let's see, 2x equals what's 29 plus 7, 36. And how do I know 2x equals 36? How do I know this is a true statement? It's because I was given something true and I added to both sides. That's the addition property of equality. And I typed it in there so I wouldn't have to write it, because writing on this is difficult. So it's not solved yet. 2x is not the solution. I have to know what value of x makes the equation true. So I have to get x equals, remember x equals is the goal. So what I'll do on this step is I will divide by 2. Because if I have x divided by 2 times 2, that means I just have 1x. So 2x's, a half of 2x's is 1x. Same thing on this side, I have to divide this side by 2 also, and half of 36 is 18. So I've got that x equals 18. That's a statement I'm making. How do I know it's true? Because I had a true statement, I had a true equality, and I divided both sides. The division property of equality tells me that must be true. So again, I would write this out, but in this case I typed it to make the presentation go smoothly. So that's how you do it. There is your first 2-column proof that you've seen. So let's see, let's do one more example here. Here on this one, I'm going to take and I have to get x by itself. So I want to get rid of this 37. So I'll have just my x's here. So I'm going to subtract 37 from both sides. So and when I do that, I will get, let's see, if I have a fifth of an x and I add 37 and subtract 37, then I'm left with just that 1/5 of an x. And on the right hand side, let's see, 25 minus 25 would be 0, so I'm going back past 0. 25 minus 37 would be a negative, and let's see, I think it would be negative 12. Okay, how do I know x divided by 5 equals negative 12? I was given a true statement, and I know it's true because it was given to me, and I subtract it from both sides. That's a subtraction property of equality. It tells me this statement must be true. And then again, I don't want x over 5, I want to solve for x. So I'm going to take this side times 5. And I'm going to take and multiply this side times 5. And that's going to give me, again, if I have x, if I divide x into 5 pieces, and I take 5 of those pieces, I have 1 whole x. So 5 times x divided by 5, multiplying and dividing by 5 cancels each other out. On the right hand side, a negative times a positive is a negative. 12 times 5 is 60, so it's going to be negative 60. I'm making this statement, x equals negative 60. How do I know it's a true statement? Because the multiplication property of equality tells me it is. I had a true statement, and I multiplied both sides by 5. That's how you do these problems. There's a 2-column algebraic proof right there. These are pretty simple ones. Here's one other. This one has 2 variables. And in this one we have to solve for y. So the point of this one is to get the y by itself. So the first thing I'll do is I'll get rid of this 12, so I'll have the negative 3y's, right? It's minus 3y, that's a negative 3y's. I'll have the negative 3y's by themselves if I get rid of this 12. So the first thing I'll do is I'll subtract 12. And that will give me, again, my negative 3y. And on this side, I have 30 x's, and I'm subtracting 12 things. Think back to the scale. The x's and the 1's, you can't combine those. So I have 30 x's and I have 12 1's. So that's just 30x minus 12. That's all we can say. We can't combine the 30x's and the 12 ones. Again, how do we know that's true? We subtracted the same thing from both sides. So it's a subtraction property of equality. Now to get rid of that negative 3, and the goal here is to get y by itself, we have y, negative 3y's. That's negative 3 times y. I'll divide by negative 3. And on this side, I'll divide by negative 3 also. And remember here, you have to divide everything on this side by negative 3. So I'm going to take, first off, the left-hand side. If I have y and I multiply and divide by the same thing, those will cancel each other out, and I'll have y equals the right-hand side. I have 30x's, and I have a minus 12. So 30x's divided by negative 3. Well, 30 divided by 3 is 10, and it's a positive divided by a negative. So I have negative 10x's. And here my minus 12, that's a negative 12 divided by a negative 3. A negative divided by a negative is a positive, so I'm going to have a plus. And 12 divided by 3 is 4. So there it is, solved for y. That was solved the equation for y. We know what y equals now in terms of x. And we need a reason for this step. Let's see, we divided both sides by negative 3. We know this is true because of division property of equality. So there's our two-column proof. And just so you know, there's a whole bunch of other properties of equality that we will be using in this course. These are them. I'm not going to really go over them now, but I want you to kind of see them now. I mean, the first one, the reflexive, that should be an automatic thing. I mean, A equals A. Of course A equals A. That's like I am me. Something like that. Reflexive. Substitution, if A equals B, well, if they're equal, you can plug them in for each other. That's substitution. Symmetric, if A equals B, then B equals A. Hopefully you can see the symmetry going on there. You just switch them around. If A equals B and B equals C, then A equals C. Well, sure, that's kind of substitution, right? You can just plug C in for B. Distributive property, hopefully you remember distributive property from algebra. So there those are. If you just do some arithmetic, then you're not really using a property of equality. Like if you have x equals 1 plus 2, if you have something like that, let me get back to a pen here. If you have something like x equals 1 plus 2, so you have something like that, and you know that's true for some reason, so you've got a reason over here, then you can say, well, x equals 3. And you're not really using a property of equality, you just know 1 plus 2 equals 3, so you did that arithmetic. Well, that's just, you just simplified. So over here in your proof, you just say, oh, I just simplified. So that's what this note down here is. Alright, well, you've got 8 problems in the assignment. It's a Google Doc. 2 questions are fill in the blank, so you'll actually have all the steps of the algebra. I'm doing that so hopefully you'll see examples in the algebra. And then on the left side you'll have all the steps, and on the right side you'll have blanks. You'll have to fill in the reasons. You'll have 4 solve the equation with 1 variable, and I did 2 examples of that. You'll have 2 solve the equation with 2 variables, and I did 1 example of that. You had an x and a y, solve for y. If you need help with doing this, I won't be here during class for 2nd period. I will be here after class for 4th period and 6th period. So hop into class, look at your book. Again, these things are from section 2.5 in the textbook. You can, to turn this in, it's a Google Doc. You can either edit it, just type in your answers, and then submit it. But again, your answers are going to be 2 columns and things like that. If you aren't good with editing a document, well, you can print it and then write on what you printed out, or you can just copy it down on paper and write on it. And then you can take a picture and submit your picture of your work. Or if you can think of other ways to do it too, I'm okay with that other ways as long as I can grade it. So I'm expecting it to be formatted like it's formatted in the Google Doc. You do number 1, then number 2, then number 3, then number 4. If you're copying it down by hand, don't do number 1, then number 8, then number 7, then number 2. You know, be organized about it. Be neat. If I can't read it, I'm not going to grade it, and it's due tomorrow. So that's everything that's going on. Sorry I missed class second period. The rest of you, I'll talk to you in a few minutes.